Hey, how's it going? It's Dan from modular.dev. Today we've got an exciting live stream. I'm going to go over what's new in C# 9. So if you're using Blazor or Unity or any kind of application that's going to be coding in C#, you can utilize some of these new features that are coming out with .NET 5. So this is a video I've been wanting to make for a while, and today we're going to go through records and Init Only Setters. The other ones I'm going to try to cover in the next video, but I might have to make 2 more. We'll see. So if you have any questions as I go through, feel free to put them in the chat. Otherwise, if you have any questions afterwards, just put them in the comments section, and I'll try to answer them. And as always, like and subscribe, and that way you'll get notified when we come out with new content. So, all right, let's go over Init Only Setters first, and then we'll cover records. I've linked this Microsoft documentation in the description below, so feel free to check that out for a full description. It's pretty lengthy, so let's just cover it in a video format, and hopefully that will help you. So let's go ahead and get started. I just got a blank program, basically, and if you don't have .NET 5, you can go out and download it. Just Google .NET 5 SDK, and if you need to upgrade your project, you're going to come in here and go to Edit Project File, and you're going to want to put Net 5.0 as your target framework. So if you don't have that, that's how you're going to that's how you're going to upgrade to it. And then if you have any NuGet packages, of course, you may need to update those as well. But we have a blank project, so we are good to go. So the first thing I want to go over is Init Only Setters. I think that's going to be the easiest thing to understand first, and then we'll get into records, which is more complex. So if I come down here and declare a class, I'll just make it person, and I can put some properties on here. So I'll put a string first name and string last name. Okay, so I can also put a constructor on here, so let me go ahead and do that. But maybe my constructor only takes in one property. Maybe it just takes in the first name. Okay, so when we are in our program, we can create a person equals person equals new person, and I'm going to pass in a first name of Bob. And how do I pass in the last name? Well, I can do a couple different things. I can put curly brackets to put in some kind of additional information. So I can put last name here as Smith, for example. And that will initialize a person with the first name Bob, last name is Smith. But maybe I didn't want to initialize it at first. Maybe I wanted to create the person and then change the last name. So I could do that. And that works just fine. Everything's going to compile, and I can run. So we don't have any errors. So that's fine. But what if, as the writer of this class, you don't want somebody to be able to change the last name after they've created the person? Maybe you want an immutable data structure, which is going to be something that doesn't change after it's been created. So in the past, how you would do that is you would put this as without a setter. So you would put get only, you wouldn't put set, and now we're getting an error saying it cannot be assigned to. So that's fine. We would try to maybe put it in here on the initializer step, but again, it cannot be assigned to, it's read only. So what you'd have to do if you wanted them to be able to set a value there is you would have to put it in the constructor. And if you did that, it would work. If you see now, I put it in the constructor. We don't have any red squigglies. We are good. We don't have any errors. But you may not want to write a constructor for all the different properties you have. And maybe there's other reasons why you don't want to make a constructor with this option. So you're kind of stuck, right? You don't want to have it in the constructor, and you also don't want them to be able to change it after it's been created. So how do you do it? Well, up until now, there's really been no way to do it, but now there is such thing called init. And init is going to allow you to change the value of this thing during the initialization step. So, for example, let's go ahead and remove this constructor completely, thus just creating a basic empty constructor. Okay, person equals new person, and if I do person dot first name equals Bob, it's going to give me an error because I'm not within that initialization step. But I can do it like this now. First name equals Bob, last name equals Smith. And that's going to be just fine. So this init here is an init only setter, and you can do it during the initialization step. So right here. After that, you cannot change it. It is set in stone. Now you can put other modifiers in here like private, in which case we're going to get an error because this is private. If you did that, you'd have to, have a method that would return a person, get person maybe, and you'd have to have it inside that class. And then you could set it just fine. Because it's private, we're still within that class, we're good. So with the same thing with set, init, you can put some access modifiers on it. So why is that useful? It's useful because then you don't have to define a constructor for every single value, but if they want to give it a value, they can. But then it gives it immutability, which means that you're not going to be able to change that object after it's been created, which is great. A lot of times we can have problems with values being changed unexpectedly. For example, let's create a function here, static void do something, and maybe it takes in a person class. And with that person, it's going to try to change the first name. Okay, right now we get an error because it's init, but let's just say we had it as set like we normally would. If we call do something on this person, this is actually going to change the underlying object. And when we pass these objects around, we sometimes want them to be guaranteed to be the same as when they came in. And in this case, imagine that this was in an external library, for example. Looks like I misspelled that. If this was in an external library, we have no idea what it's doing to this person. So if we know it's immutable, then we are guaranteed our same exact object back. So let's go ahead and run this just so you can see that it actually does change the person. You probably can't see it, but if you look, we have first name as different name now, whereas before it would have been empty, I guess, because we didn't specify. So that is how a class would typically work, and that you have problems potentially with functions changing values of your type. So that's what this init only thing is good for. This function is not going to be allowed to change this anymore. So we're guaranteed that the object that we get back is going to be the exact same as the object we put in. So that's init only setters. We can use them in classes and structs. So let's go ahead and create a person struct. First name. And let's put last name here. So you'll see we have the exact same thing, and it works as a struct. So I could put, instead of person, I could put person struct. And I'll just get rid of this for now. And if I try to change something with the person, I have the same error because it's an init only setter. So that's how we can use that, and I do recommend that you do use it if your goal is for your type to be immutable. Okay, let's go back just a second, and we're going to cover records now. But in order to fully understand records, I think it's important to fully understand classes and structs. So if you already know everything that you need to know about classes and structs, you can probably fast forward a bit. I'll link the timestamp to where we get to records at the end after this video is over. But for now, we're going to talk about classes and structs and what the difference are. So I'm gonna rename this to person class just so we can know the difference of these two types. So if we have a person struct, it's important to know that this person is passed by value, and it's compared by value. So let's go ahead and actually create a person struct with first name equal to Bob and last name equal to Smith. And let's duplicate that person. Let's just create a whole new one. So person 2. So what happens if we try to compare them? If we do let's do right line persons are equal, and we'll do that if person equals person 2. Else console.writeLine persons are not equal. Okay, so if we run that, we should oh yeah, we would need to override the equals operator if we wanted to compare structs, but we can just do dot equals, that's fine. So we're going to compare to see if they're equal, and then if they are, we'll get console.writeLine persons are equal. Let's go ahead and do it. And I'm going to bring my debugger over here so you can see. And it says persons are equal. Hopefully you can see that. And that's because structs are compared by value. So if we change this to Johnson, and then we run it, we're going to get, let's see. Oh, I'm at a breakpoint. Okay, we're going to say they're not equal, and that's because we're comparing by values. All of the values are not equal. So let's go ahead and try the same exact thing with a class. So person class. I'm just changing those from person struct to person class. And we'll put this back to Smith. So they both have the same exact values. And now if we try to compare, they're actually not going to be equal. And that's because they are in different spots in memory. So classes compare by reference, or where they are stored on the computer. And I don't need to go necessarily into that too deep, but think of it as, when we're comparing them, when we're checking to see if they're equal, we can do equal here as well. We're going to check to see if their memory references are the same. In this case, they are not. Now, if we did, let's say, person class person2 equals person, we just assign it person. Now they will be the same because we're actually, when we do an assignment, we're assigning it by reference. We're assigning a reference to that same spot in memory. And if we write this out, they are equal. Now, something to keep in mind with classes then is if you change person2 dot first name to Tom, this is actually going to change both person2 and person. Oh, I can't change it because it's init only. So let's go ahead and put that as a set for now. and run this. So person2.firstname is Tom, but person.firstname is also Tom. So because we passed it by reference, if we make a change to it, it's going to update both copies. Alternatively, if we do it as a struct, let's put this back to struct, and we do the same exact thing. Oh, we are got to change those back to set, and we'll get rid of this for now. So person2.firstname is Tom, but person.firstname is Bob. And that's because when we copied it, we actually copied each value of the struct. We didn't copy the reference, the memory reference of it. So that's why changing one does not change the other. And those are the fundamental differences between classes and structs. Imagine also we had a function that took in a struct or a class. So if I make a function called alter person struct, and it took in a person struct, and I did person.firstname equals different. And now if I tried to call that, let's get rid of this. If I tried to call that alter person, oh, it's got to be static. Alter person struct, and I pass in the person. This will work, but when we come back, it will not be altered anymore. So let's step through it so you can see. Right now, the person's first name is Bob. We go in here, we change it to different, and we look here and it is different. But then when we come back, it's back to Bob again. So why is that? It's as we talked about before, when we copied this, we copied it by value. So when we actually pass this in as a parameter, it's making an entire copy of that object, which can be quite slow and memory intensive if you have a big object and you're copying and you're calling lots of functions with it. This whole thing needs to be recreated, and the other copy needs to be stored as well. So passing by value is not always the greatest way to do it. But if we did a class where it's passing by a reference, you know what? I'm actually gonna I'm just gonna create another method here so we can kind of keep them separate. Person class. Okay. And update these ones. Let's go ahead and step through this. We come in here, we have a reference to person. We update the first name, and now it has been changed. And when we come back, the original person is also changed. We talked about this at the beginning, right? So that's the difference between classes and structs when we're passing by reference versus passing by value. So how do you get the best of both worlds? You copy it by reference, so you're not doing memory intensive work necessarily, but you're guaranteed that it's going to come back the same. Well, we talked about that. That's what the init is going to do for us, right? But it also is kind of nice sometimes to do like what a struct does and compare by value. So when we say, is this struct equal to this other struct, we compare each of the values in there instead of comparing them by reference. So each version kind of has its own pros and cons depending on your use case. And up until now, if you wanted to make a class that compared by value, you would have to, override the, the equals. Why is it not? Because it's public probably. Yeah, okay. You would have to override the equals, and you'd have to go through each property and compare that they were equal. And you'd have to override the equals operator, and you'd have to do that for every class that you made that you wanted to have it compare by value. So I think that's about it as far as classes and structs. Oh, one other thing about it is, if you wanted to create a student, let's say a student class, and you wanted to inherit from person, and then give it some additional values like grade or something. That's perfectly fine on a class, but on a struct, you cannot do that. So if I create a struct, student struct, inherit from person struct, I am going to get an error. Type person struct in interface list is not an interface. So what it's basically saying is, for a struct, you can only implement interfaces. You can't actually inherit from a base class. So that's a limitation on structs. So with all these limitations, but all these kind of advantages that structs give us, there was a need to have an additional data type, I guess you could call it, or a way to declare a type, and that is a record. So if this is new for C#9. So a record is another way to declare a type, as I was just saying, and on the surface, you can do the exact same thing as a class. Whoops, that should be person record. So if I create a alter person record function like I had for the other two, and I pass in a person record, I can change its first name. That's fine, because it's not just read-only or init. It is a set. And if I do person record up here, and I come back after that, remember we said, well, I don't think I said it yet actually. Records are passed by reference. They're not passed by value. They're passed by reference, but they're compared like a struct, where they're compared by value. So that's kind of nice in certain circumstances. So let's go ahead and run this, and you can kind of see we're going to create a record called person. We're going to call in alter person record and change its first name. Now when we come out of it, the person's first name has been changed. So that kind of proves that it's by reference, right? Because we got the same reference back to it, and it was altered. Now, that in and of itself isn't that great, but like I said, you can create another person record now, person 2, and I can do if person equals person 2, console.writeLine, persons are equal, else console.writeLine, persons are not equal. So if it was truly by reference and nothing else was changed with it, remember classes, this would be false, and we would say persons are not equal because the references, the spot in memory is different. However, their values are the same. So if it was a struct, it would come in here. So let's see what this one actually does. And you notice we're coming into this true branch, so they are considered equal. And what's actually happening, like I was saying, is a record is going to be comparing by value, but it's going to be passing itself around by reference. So that's kind of the difference between structs, records, and classes. Now, that in and of itself is very useful. But like I said, there's nothing new that we couldn't have done with a class if we wanted to override the equals operator and the equals function. But it is kind of nice to have that built in. So with that being said, records are kind of intended to be immutable. They aren't required. I can put a setter on here, but they're kind of recommended to be immutable so that after they're changed, you can compare them, and if they were equal at one point, you're guaranteed that they're always going to be equal. The actual instance of the record is not going to be able to be changed in any way. That's kind of the goal of a record, but like I say, it's not required. So let's go ahead and see. Now we get this error because we put an init on here and we can't change it. So just keep that in mind. That's kind of what the point of a record is, but it's not, like I say, it's not required. All right, I'm going to get rid of these. I think that's all I really need to do with structs and classes, so I'm going to get rid of these two just to clean it up a bit. So we have a person record. Now, what else could you do with a record? You can use what's called a with expression, and they talk about that in the documentation. If we scroll down quite a bit, let's see, where is it? Right here. Finally, records support with expressions. So what you can do is I can create a second person. Person2 equals person with, and in there I can put whatever different things I want. So maybe I want first name equal to Tom. So what is that going to do for me? That's going to copy the entire person record, but it's going to change the first name to Tom. And if I go through this, and I kind of put my mouse over it, you'll see that the first name is Tom and the last name is Smith. So that did work, which is kind of handy, especially if you have really long types, with many properties. You want to copy it, but you only want to change a couple things. This can be very useful, where you just kind of change that right there. Now, the other thing that records are going to be very useful with is destructuring. So we're going to talk a little bit about tuples now. Tuples were something that came out, I think, in C# 7 or 8. I can't remember for sure. So a tuple, you may know, is a collection of variables, I guess you could say. So if I create a tuple like this, I can have, let's see, I could have string first name, string last name, and string grade. And then I could set it equal to Tom Smith, he's in first grade. So I can do that, and this is kind of cool because now this is kind of a destructured tuple here. So I have access to first name. I probably should, okay, let me back up just a second. This over here is a tuple, and it's being destructured into three variables, one called first name, one called last name, and one called grade. Now I could, if I wanted to, let's make a different variable called var person and set it equal to that tuple. So now I could do person dot item 1, which is that person's name or first name. I could do whatever I want with it. And same thing with the other ones. I could do item 2 and item 3. And it's kind of cool because that way you don't have to declare this as a type. You can kind of just mash whatever types you want into a thing. It's very useful if you're only going to use it a couple times. But if you're going to use it over and over and over, I would definitely recommend creating it as a separate type so that you're not always doing that. But you could have a function that returns a tuple too. So maybe I want to return string int, I guess. Get person, and it's going to return Tom Smith, and he's in first grade. So now instead of just setting it to that, I can say get person. And now I have access. Static. And now I have access to all that information, which is great. You can also name whatever you want on these items in the tuple. So I can put first name here, last name, and grade. It's kind of like creating a type on the fly, but being able to reuse it. So I could do person.firstname, and that would be fine. So this is not necessarily new for C#9. This is something that came out a little while ago. But up until now, if you had a class, you had to create a deconstructor to be able to deconstruct that into a variable or like a tuple. So for example, if I do get person is going to return back a tuple, right? If I say string first name, string last name, int grade, and I set that equal to get person, now I can use those as variables. So I could do console.writeLine first name, whoops, console.writeLine last name, and console.writeLine grade. So let's go ahead and just do that so you can see. All right, and there it is, Tom Smith 1. So that is destruction. That's called destructuring, where we take a tuple and destructure it out into different variables. And if you were going to do that with a class, here's how you would do it. You say public class person class, and maybe it has a first name. Whoops. Public string first name, public string last name, and public string grade. So you'd have to create a, I think this is the syntax, void deconstruct, and you'd have to say out string first name, out string last name, out string grade, and this would be a function. So you would set first name equal to first name, last name equal to last name, grade equal to grade. And that's a lot of work, especially if you have a lot of properties, having to create this deconstructor. But it does work. So if I come in here and I create, let's change get person to return back a person class. And I create a new person class. First name equals Tom, last name equals Smith, and grade equal 1. Oh, that's supposed to be a string. Okay. So I'm returning that back. Now, I think I can do it like this. Let's see. No suitable deconstruct instance or extension method was found. Maybe it has to be public. Let's just see. That should be fine, but let me just double check. Let me bring up a deconstruct method C#. Okay, yeah, it looks like it started with C#7. So let's go ahead and find this public void deconstruct out string. Oh, I think it has to be like this. Maybe. Hmm. I'm not really sure. I thought that's how I did it before. But anyway, you can see it's a little bit confusing, right? How do you deconstruct this class into a tuple, or variables that you would get out of a tuple, rather? So this deconstruct thing usually works fine. I'll have to look and see what I did wrong. Probably something simple. But with a person record, it's actually much, much easier. So you can actually put, it looks weird, but after the type name, you can put the actual properties that you're going to have in your type. And that's all you really need. This is called positional records. So it's actually declaring, behind the scenes, it's declaring those two properties in the same way with a getter and an init setter. But now because we have them populated positionally, we can actually deconstruct those as well using that same kind of deconstructor kind of way to do it. So in this case, I'm going to return back a person record now. And let's get rid of these. Oh wait, we have to fill out the constructor. Tom Smith. Okay, and now when we call get person, we don't have a grade now. We just have first name and last name. And now it works just fine. So we have access to first name and last name being deconstructed out of this person record, because the deconstructor is actually defined at the same time the constructor is defined, which is kind of cool. And you don't have to, you could do something like, well, no, that's fine. Let's just stop there. So you have a person record getting returned back from this function, and you can deconstruct it into those variables, and then you can use those variables there. So if you do declare your record this way, it's actually really simple. Now you have a one-liner, but if you have a lot of things in there, it's going to get quite long. You can also declare additional things in the record that wouldn't be in the constructor. So I could say string, I could say public string grade, and I could still have that property, but now that property will not be written out by the deconstructor. So that is kind of a good thing to know. You can also put functions and things like that in here too. Get name, for example, and return first name. So if you do it this way, by putting the constructor up in here, you're going to have a constructor written and a deconstructor, which is really nice. So records, I think just in general, between with and the deconstructor and the default init setter thing with the positional records, I think between all that, I'm actually going to use records quite a bit, especially for things that I want to be immutable and that I want to compare the values on instead of the reference. There are a lot of times where you do want to compare by reference, but with records or with structs, in the past you didn't want to. And records is going to give us the best of both worlds of structs and classes. So I think I'm gonna use them quite a bit. I actually really like them, and being able to copy them with the with expression and deconstructing them out, I think it's really beneficial to start using those. So next time, like I said, we're going to cover the rest of C# 9. We might not get through everything. We might have to have 2 more videos, but we got top level statements, pattern matching, which I'm really excited about some of these pattern matching things, function pointers, native sized integers, targeted type new expressions. That's, for me, that's a huge one, and more. So we'll cover some of those next time. But I hope you enjoyed this. If you did, give it a like and go ahead and subscribe to the channel. And feel free to write in the comments if you have any kind of other topics you want me to cover. And I'll try to get those in the future. So thanks for watching.